So we're going to take a couple minutes and start on the surface area of pyramids and cones. So these are polyhedrons. Remember, they're all polyhedrons, but they have specific names based on their shape. So this particular one that we're talking about right here is pyramid. So this is the pyramid down here. So a pyramid is a polyhedron with one base. Okay, and the rest are lateral faces. So one base and the rest are lateral faces. Okay, so remember, lateral faces are like the sides. So there's 1, 2, 3, 4, 5, 6 lateral faces in this particular situation. Okay, and then there is that one base at the bottom that happens to be 6 sides. And since there are 6 sides, we know that it is a hexagonal pyramid. Okay, so the base is a hexagon, so now we know it's a hexagonal pyramid because it has a hexagon for a base. So if it was an octagon for a base, it would be an octagonal pyramid. So we name it by the size of its base and then the fact that it's a pyramid. All the lateral faces meet at the top at that one spot. Okay. The altitude is the perpendicular distance from the vertex, that's this point at the top, to the base at the bottom. So if I were going to draw that in, I'm going to draw it in a different color. I'd be starting at the vertex, and it would be the perpendicular line that goes right down to the center of the base, okay, and makes, sorry, that's a little bumpy, and makes a right angle with the bottom. So the altitude, perpendicular. So right away you know it's a right angle. Okay, so perpendicular forms a right angle. So it's perpendicular from the vertex to the center of the base. Okay. So the slant height, though, is different. The slant height, and again, I'll do that in a different color for you, is from the vertex, but it's down the side. It's as though you were riding your sled right down the side of that pyramid, and you end up in the middle of one of the sides. So the slant height is the height from the vertex. The height from the vertex perpendicular to the edge of the base. So it still forms a right angle, but it forms a right angle with the edge of the base. Okay, perpendicular to the edge of the base. So edge of the base, and the altitude is to the center of the base. So that's the difference between the two. Okay, you're going to need both of those in order to continue your work. So we are going to clear the page, and we are going to scroll up, and we're going to actually look at these two formulas. So we have, again, I want to just kind of point out some things to you in the pictures, and then we'll move on to the next page. So again, perimeter is around the outside edge. This is how we find the perimeter. So it's the outside edge of the base. Okay, that's the perimeter. And then don't forget that L stands for slant height. Okay, so the L, you can see, comes from the very, very top, and it's like you're sliding down the side of the pyramid, and then you're forming a right angle with the base. So that's your slant. Okay, and you'll need that for your formula. And then, of course, the other piece, so this piece, this right angle, that goes to the side from the center of the base to the side of the base, you can see it forms a triangle here. That is your altitude. Okay, so the altitude and the slant height sort of form a triangle. So the slant height is like the hypotenuse of that triangle that's formed there, okay? And the altitude is like what we consider to be the long leg. Same thing happens in your cone. You've got your altitude that starts here and kind of goes straight down and forms a right angle. So that's your altitude, okay? And then your slant, right? And then your radius, of course, from the middle to the outside edge of your circle. So just some keywords there for you to know. Now let's actually practice doing a few of these. So let's look at these first two. First thing we have to figure out is what formula do we need? What are we dealing with? What formula do we need? So in this first example, I need to know surface area. So the surface area equals the lateral area plus the base. So again, my base is a rectangular sort of figure, and the area of a base is length times width, okay? And my lateral area here is going to be 1/2 times the perimeter times the slant height. That's your cursive L. We're going to add that to our length and our width, our base, okay? So the perimeter is all the way around the outside edge. So 8, 8, 8, and 8. So I have 8 times 4, or 32, times my slant, which is given to me, 7.2. Lucky for us, they gave it to us this time. Plus, and now I want the area of my base, which is going to be length 8 times width, which is, times width, which is also 8. And I just have to add them together. So 1/2 times 32 times 72 is 115.2 plus 8 times 8, 64. So I get a total in number 1 for 179.2 inches squared. Okay, 179.2 inches squared. Sorry, I scribbled right over the top of that. I'm trying to get used to this new marker, and it's not always as easy as it appears. Let me try that again. So 179.2 inches squared. Let's see if I can not draw over it this time. There we go. Okay, number 2. So you'll notice I'm doing this the same way every time. I always start with, what is my formula? Surface area equals lateral area plus the base. So my base this time is length times width. Love it. Makes it easy to do. Okay. And then the surface area is, the lateral area is going to be 1/2 times the perimeter times the slant height. And that's going to be the whole formula. So they do not give us they didn't give us the slant height this time. So we're going to have to actually do some solving. Okay. So I do have my altitude, and remember it forms a right angle and gives me this position, and it gives me this slant. So if I redraw that, I have my altitude, which is given to me as 6. I'm solving for my slant. That's a cursive L that I don't know. And then this piece down here from the center to the outside edge is exactly halfway from one side to the other. And from one side to the other is 4, which would have to make this piece 2 and that piece 2. So that means that the bottom part of my triangle is a 2. Okay. And so I need to solve for that missing side. When I have a right triangle and I'm only missing one side, I can for sure use the Pythagorean theorem, right? C squared equals A squared plus B squared. So I'm going to do that. This is my hypotenuse. L squared equals 2 squared plus 6 squared. So 4 plus 36. So L squared is going to equal 40. And to undo a square, we take the square root because they're inverses of each other. And that leaves me with L is, and the square root of 40 rounds to 6.3. We always round to the nearest tenth. So I have my slant height. I can get my perimeter because perimeter equals a side times the number of sides, and there are 4 sides, so my perimeter is 16. And that's all I need. I have length and width, 4 times 4. So I have 1/2 times my perimeter, 16, times my slant height, 6.3. I'm going to calculate that all out, and then I'm going to add it to my length times my width, which is going to give me 16. So this first part, 1/2 16 times 6.3, 50.4. Add it to 16, gives me 66.4 meters squared. Awesome. Okay, let's clear the screen. We have 2 more to go. I'm going to just scroll this down and do these last 2. Okay, so again, surface area equals lateral area plus the base. So my base is a circle, which means I'm going to need the area of a circle, pi r squared. Okay, and then I need my lateral area, which is going to be 1/2 my perimeter times my slant. So the perimeter of a circle, remember, we talked about this last time. The perimeter of a circle is the same as its circumference, right? And the circumference of a circle is equal to 2 pi r. So that's going to replace perimeter. So 1/2 times 2 pi r times the slant. That's my lateral area, plus the area of my base, pi r squared. So I need r. So my radius, I need r. That's going to have to be 1/2 of 6. 3 and 3. So I have r. And now I need the slant, which was given to me as 8. So I have everything I need. 1/2 times 2 times pi times my radius of 3 times my slant of 8. I calculate that all out, right? I'm going to get 75.4. Okay. And then over here, I'm going to have pi times radius squared. So when I do 9 times pi, I get 28.3, and then I add those together, 103.7 feet squared. All right, the last one is probably the most challenging, again, because it's one of those bases that is difficult to find the area of. So surface area equals, lateral area, I should say. Lateral area plus the base, and the base is a hexagon. So that means I need 1/2 perimeter times the apothem. All right, and then the first part is my lateral area, which is 1/2 the perimeter times the slant. And we have the slant, so that's awesome. And I can get the perimeter, right? The perimeter is going to equal my side 8 times the fact that there are 6 sides. So my perimeter is 48. So I got that. Awesome. So I have perimeter, I have slant, I have perimeter. The only thing I need is apothem. So again, I got to draw that in. That's my apothem. From the center to the center of a side forms a right angle. So there's my triangle, okay? So if I draw my triangle over here, apothem, the whole piece here is 8. So this is a 4 and a 4. So this is a 4. I just need to get my angle. Remember, to get my angle, I do 360 divided by the number of sides. So 360 divided by 6 gives me 60. And 60 divided by 2 gives me 30. So this is a 30-degree angle, which means that I can deal with a 30, 60, 90. And so just to switch up the colors so you can remember this, across from your 30 is your n, your hypotenuse is 2n, and the other side is n square roots of 3. So if I know n is 4, I just have to plug it in. 4 square roots of 3, and that is roughly, when it's estimated, oh, I guess I don't have it. I have 13, so it must round to 13. So let's go ahead and calculate. So I have 1/2 times the perimeter 48 times my slant of 13 plus 1/2 my perimeter times my apothem. Oh, sorry, my apothem is not 13, it's 6.9. I was looking in the wrong place. My slant was 13. So my apothem is 6.9. That's what 4 square roots of 3 rounds to, 6.9. Make sure you fix that, 6.9. Okay, so on this side of my equation I get 312, and then on this side of the equation I get 165.6, and when I add them together I get 477.6 centimeters squared. Perfect.